Hi, everybody. Welcome to Morehouse Calibration Software Release Webinar. New updates to our free calibration software for HADI 4215, G501F, C705P, and more. We have, and I'm asking people, I plead with people, I beg people, go to our YouTube channel. We have videos galore. This presentation will be posted on YouTube if you're not already watching it on YouTube. Videos on measurement confidence, uncertainty, TAR, TUR, lots of concepts that we've tried to simplify. Also on using our equipment. Almost any webinar we have is there. There's a link to the free download page. That's where you're going to find our software. You're going to find CMC calculation uncertainty sheets. You're going to find mass to force, force to mass stuff, TUR, risk, how to calculate coefficients, a coefficient calculator. We also have an ebook. Very proud of this. This is about 200 some pages of all things force related. It does talk about coefficients in there and some of the things we're going to cover today. And then the most relevant paper to this conversation is the one in the bottom, and it's converting a millivolt per volt load cell signal into engineering units. What is the most accurate and cost-effective way to use a calibration curve? Cost-effective is to use our free software, just saying. What's the problem statement? What problem are we trying to solve? Zach's going to go over all this stuff. What are we trying to solve here? Here's a 2-point span calibration. You know, most meters that you get out there, the run-of-the-mill ones, are using some type of span. They might segment a line. They might just do a 2-point cal. They might do a 5-point cal. They might take average. All different firmware and programming, which Zach knows all too well from our C705P meter troubleshooting as we were doing the firmwares and the upgrades, where that meter can do a 7-point span. It can use coefficients, can do all kinds of things. Our 4215, which is, it can do 2-point spans, 5-point spans. The 4215 plus can do can use the coefficients. So that's a more expensive meter compared with the C705P. But what this is showing is here, programmed at 0 and 5,000 pounds. That's what the really type of capacity the load cell was. And we did this simulation and we said, okay, so I program it at 2 points. What's the difference? And I programmed these in millivolt per volt span calibration. You could do, people that program these know, sometimes 20% and 80% works better than 0 and 100. Sometimes 0 and 70 works. There's all rhymes or reason. In any case, if you're doing it, trying to tweak this in, because we're a nation of tweakers, trying to tweak this in to as good, as close as possible to nominal to eliminate some bias, you know that it is a headache on epic proportions, and after a certain amount of time you become familiar with a meter, and then you say, hey, these meters work best on 0 to 80%. Now I know how to make them work great. What happens when they come back in for cal and they've drifted? You start having other problems. So anyway, difference, what we're showing here is overall about a 0.09. Some people say, that's not much. Some people say that is a lot. So remember this slide, 0.09 on a 2-point calibration. Now we switch to a 5-point calibration. That first point's a little, is going to be the largest one on this set, but now we're down around the 0.5, so almost twice as good. Better characterize the error, but the problem is, at least for me, there's still a relatively large error bias. And when we say bias, just to be clear, we had this in the last webinar. If you haven't taken the webinar on bias, highly recommend it. We have a nominal value of 10 and a measured value of 10. That's on the left here. We can basically say, hey, to our knowledge, since they match, there's really no bias. And then on the one on the left, the one on the right here, we have a nominal value of 10 and a measured value of 11.75. As you can see, it's plus 1.75 from the nominal value. And we've drawn a little curve that would have some repeatability conditions and measurement uncertainty and all that fun stuff is in that normal distribution. And that's what we're talking about. Pretty easy concept. And then we have this, which is most force systems. This is not the 4215. This is a meter that's programmed with a 2-point adjustments. and it's programmed at 1,000 and 10,000 pounds. You know, the first point we applied was 200, but we programmed it at 1,000 and 10,000. And the program points, calculated values, and then the errors. If you look at this, at capacity, it's out 1.3 pounds. Overall, percentage-wise, that's relatively low. But in the middle, where what happens with load cells is they're generally not linear. And this is where I get the fun with doodles, because my mouse works, and you say, I have a straight line. What are we talking about with linear behavioral load cells? Most load cells are going to do something like this, where they're going to deviate from linear. And you can see that, or linearity is going to be the worst at like 20 to 40%, 20 to 60%. But you can see that in here. At 20 to 60%, you generally have the worst numbers, and that's this to here. But if we look at this error-wise, we're 3 pounds out at 3,000. Right? So much larger number than 1.3 pounds out at 10,000. So most meters do this. They use a span adjustment. Load cells aren't linear in general, and the result is a larger error source or bias. So what else happens? So we have the 1,000 and 10,000 points. These are the ones that we just had. Measured values. There's our 1.3 pound out. And we adjusted. And maybe somebody says to us, hey, I want you to do a conformity assessment, and our tolerance is 0.1% of full scale. And I want you to adjust it better than plus or minus 10 pounds. So in 2023, we do the calibration. It passes. It's well within. I mean, we're within, 1.3 out of 10,000 is 0.013 of that, right? What happens in 2024 if the meter just wasn't a really good meter? Purchasing said, hey, that's a nice $200 meter by XYZ, Acme Calibration. That's a nice load cell by Acme Calibration or Acme Manufacturing. And they bought this. They pay $400 for the system, and then they pay more than that for us to calibrate it, which is kind of silly in its own sense. But they don't buy good equipment. What happens? We have drift. And then when we have drift, not only does it drift out of spec, but now we have this scenario where that 9998.7 now reads 10,018.7. So we have an as-received calibration. Typically, someone's going to want adjustment, so there's going to be more work to adjust it in. And we also have a question on our reliability. And we're constantly tweaking the numbers in to adjust them back closer to nominal, which Deming has a quality funnel where you try to drop marbles, if anybody's ever seen it or been part of it, where you have a funnel. It's the Deming funnel experiment. You can look it up. You have a funnel, you drop a marble drops on something, and then you adjust the target, drop it again. And when you're constantly chasing these numbers or adjusting things, your overall uncertainties get much, much larger, as if you would just leave it alone and not adjust it. Paul Reese actually has a really good paper on this that we can provide, or I can look for what Zach's talking and hopefully maybe find a link to it. He presented at NCSLI, but if anybody wants it, they might have to get it because it might not be available online. But in any case, if it drifts, we have that scenario. The other assumption is that people do is they say, okay, well, I want to handle my risk is I just want to make sure you're 4 times better. Doesn't impact what the slide I just showed. A 4-to-1 TR doesn't do anything for that location of the measurement or the drift or any of that stuff. And it also assumes that all measurement biases have been removed. So basically, if you're doing uncertainties, the reason this slide made it back here is if you're doing uncertainties for your system and you have these biases and are not accounting for them, this is a garbage scenario because it makes the assumption that all biases have been removed. In fact, most papers make that assumption. If you go read them, the requesting of a 4-to-1 TUR and everything else, guess what? They all assume this process is centered and that you've corrected known biases. NCSLI RP 18 addresses this. That was made in 2014, even before the new standard came out. And if there are scenarios cannot be removed, the TUR will not account for the increased risk, and that's where the webinar and bias comes into play. So let's come back at this 5-point cal error. What happens when we use coefficients. And why would I use coefficients the way Zach's going to talk about our program today? So 5-point cal, errors around 0.5, 0.54, 0.55, 0.58, whatever. And then if we use B coefficients, and that's this coefficient method where we can actually better characterize the load cell. When we draw this curve again, what these coefficients, second and third order, are doing is basically saying, hey, I have my y equals mx plus b is your traditional algebra. Probably all of us remember plotting it, doing things using a graphing calculator, whatever. Now we're adding x squared and possibly a cubic to the whole equation, and now we can characterize this curve. Exactly. We're not just trying to draw a straight line through it. We're adding like the additional polynomials to tell it to, hey, I want it to take this form and I want it to come up and do this here. And when these characterize the system, the error is minimalized. Very careful on my wording here. It's minimalized. There still could be interpolation error, but it's one of the main benefits. If you look here, there's a difference somewhere in this equation, right? I took it out 3 decimal places. Maybe the 4th or 5th decimal place, we're going to have some error. It's natural. But again, when we're talking about this decimal place right here is 10 parts per million, one more decimal place would be 1 part per million. So when our errors are under, and I believe it was like 4 or 5 decimal places to actually see anything on here. So we're talking errors in like the 1 part per million, 0.1 part per million, in a lot of cases from using coefficients. Really, really low. And some may be out there saying, hey, what are coefficients? Well, here's an example. Basically, what you're doing, if it wasn't clear early, you take the force applied values and you plot them against these measured values to generate this curve. So I have one set that's going to be on my x-axis, another set on my y-axis, and I'm going to generate when it's millivolt per volt, and I want to solve for force, I'm going to use this set of coefficients, meaning I have this set up here. I can plug these into this equation, and they're going to spit back my force value. And a lot of people confuse the x and y axis, and it's okay because during testing, when you get it wrong, you'll just have them backwards, and as soon as you swip them, as soon as you change them, they will be right. And it's what you call x or y when you're using Excel, but it's super easy, and we've done it. In fact, if I were to do this in front of you today, there's probably a 50-50 chance that I would confuse the x and y axis the first time through until I say, oh, okay, yeah, do that. In any case, the formulas work. Really easy. Response, fitted curve. If I know my response, I can solve for force, and if I know my force values, I can solve for response. That's how it works. Now, there's meters. Not very many meters in the marketplace that do this. We have many options in systems. Some people here are using the 4215. Some people are using the Hattie. Some are using the DSC. Zach's already also programmed in the G501F, another indicator we offer. But these, if you say, I don't want to use any sticking software, I don't like computers, I don't like anything else, these 2 meters would offer a standalone solution where you could program coefficients in without the use of any software. That's why there's pictures here. This one is the economical model. I wish I had the price off the top of my head, but I can say it's probably, I think it's around 1,200. It's around the same price as a known instrument that does a 10-point or more span and has 10 or more channels. And this one is a more higher end meter that's about 2.5 times a little more than 2.5 times the price. So it all depends on what you need or what you want. The big benefit of this is when I talked about drift and everything else is they minimize the measurement bias, whereas the other thing is you can get an as received cal that matches your as return cal. So we don't have to be that nation of tweakers. We can look at the millivolt values on the as received and on the as returned, and the only adjustment we're making in these meters, we're just giving you a new set of coefficients that you can enter in if you want to do it, or that we'll enter in at the time of calibration. All it is. Your cal reports stay in the same unit, and you can truly track that standard, not knowing how many times it was adjusted. Because those that are tracking their standards, as soon as it was 10,000 in 2023, 10,004 in 2024, 10,008 in 20, and then you adjust it. As soon as you adjust it, that history kind of gets really muddled and becomes difficult. Not impossible to trace, but super freaking difficult for anybody that has done it. So that leads us to what Zach is going to present. He's sitting there chomping, he's waiting, he's super excited, and that is our new software and a lot of work that Zach's done. Zach has joined our team, and we call him numerous names, but I like to call him our software guru. An incredibly sharp person. I have the absolute privilege to work with him as a team member. Cannot say enough good things about him. And I've already told him that if he messes up, who cares? Because no one's really gonna care at the end of it. This is for everybody that's watching or participating in this to learn the features and benefits and maybe some helpful tips and tricks if you're using our software to make you more effective and efficient. So yeah, Zach's gonna go. So with that, I'm gonna do this, and I'm gonna talk briefly and hand it over to Zach, and you're gonna see how easy it is used, the benefit of improved measurement capability, workflows. Hopefully, Zach has caught a lot of those bugs, error reduction, Excel reporting, and some additional features. Zach's going to cover UI improvements. He did a form redesign, which we think it flows better now. Data storage, certificate importing, drag and drop certificate PDFs, which is super cool. The support for the new meters. We also have the other people's meters, interface, Toby, the other ones, working shell terminal. Again, he's done just a lot. Supports up to data up to 5 runs if you want to use it to do repeatability studies, which are required as part of measurement uncertainty. Hopefully the AVs are enforcing that. Some are, some aren't. Anyway, there's so many additional tools or additional uses that this software can be used for. And then you have the PDF. So with that said, I'm turning this over to Zach if I can figure out how to use, where'd Zach go? There he is. There he is. He's still green. So Zach, you are now the presenter. You take it away.
Awesome. Thank you, Henry. As always, your knowledge definitely exceeds my understanding. I think some other people in the room might feel the same way, but
no one ever, never. But thank you.
So just kind of give everybody a heads up. This is my first webinar, first time presenting. Anxiety is obviously a little high, so I'm going to do my best here. But the goal today, as Henry mentioned, is to cover the new changes to the software. I'm going to be reviewing some of the usage of the software as well, some things you guys may or may not know. I do recognize a lot of names in the chat that I've helped personally already. As always, if you have any questions, definitely reach out to us. Either myself or somebody in the sales team or somebody else at the company will definitely help you out, get your problem resolved. That said, I've been working on this update for about 3 months now. In the last 48 hours alone, I have made over 30 changes because I've kept finding more issues. We ran into some technical problems getting this uploaded, but everything is online right now, and I'll walk you through how to download the latest version so you guys can work with me or save it for later. So to get started here, I'm just going to go over, this is version 106. This is the one that most of you guys are probably familiar with, or a version very similar to this. As always, your coefficients are stored here. Each one of these are your load cells. I just have some test cases in here so you can see that the migration to the new version will carry everything over for you as well. And I'll cover that in a moment as well. So we have a test one here for compression, pounds, 0, 1, 2, 3, 4, so on and so forth. I'm going to search for some indicators here, just kind of assign those load cells there. One of the things that's really nice about our software is that we have problems, apparently. This was actually fixed in the next version after this that you may or may not have yet.
We'll get it uploaded this week. It won't be a...
Yeah,
for those watching the webinar, it will not be any problem whatsoever.
All right, so anyway, the coefficients are already up. Like I said, this is the old version, one that we're not using anymore, and the instruments are still here. So what I'm going to do is I'm going to show you how to download the latest version. Go to our website. Up here, documentation tools. There is a software tab here. You'll click on that, and I'll bring you to the page that Henry was showing a little bit before the webinar started. Down here, the third option is the Morehouse Calibration software. We are currently working on getting a dedicated software page up and running. It is not quite live yet, but we're thinking within the month or so. For the time being, we do recommend everybody go to the new release page. This has links to the software itself and the manual if you want to download them separately. Once you click on this, it'll just download the news version for you.
Maybe. It might say, are you sure you want to download it? Yes.
Yeah. So once you have it downloaded, you see here it downloads a zip file for you. You do have to extract the files. And then inside of there, you see the instruction manual, and you'll see the latest version, which is 1.20. As you'll notice, there is no longer a setup.exe file. There's no longer the SQL Server Compact Edition. I know that some of our customers have had issues actually getting that installed at their company. Instead, there's just an MSI, and you guys may be prompted with this message. This is just saying that it was downloaded from the internet. We don't know who it came from. Are you sure you want to install it? Some companies may or may not have that, and you'll just click Run Anyway. Then you'll get this little walkthrough how to install it. You can change where it is installed to. And just that easy, it's done. Now I already have all the drivers for the meters installed on my computer. I do a lot of testing with the meters here. For those that are installing this onto a new computer, or you guys have received a new meter that you haven't had previously, you may have to install some of the drivers. So 4215 has a driver here. You would just run it, and it'll walk you through another installer itself. Like I said, I already have all these done, so I don't need to, but all of them are listed here for you. And then once it's installed, you just run the program, and as you can see, it looks a little different than the previous versions. One of the things that Henry has already mentioned is I do have light mode or dark mode enabled. Completely up to user preference. This is based off of the computer's theme. So if your computer is normally light mode, which is default for Windows, it will default to light mode. So you don't have to worry about using it if you don't want to. But like I said, that's completely up to user preference. Some people do prefer the better or the different contrast here. One of the things you'll notice is, even though this is a new version, and I'm going to cover a lot of the changes here, is all of your data has migrated over. So all the load cells that we had previously, the information is still here. Save you guys time from having to type everything in again. But one of the things that I do want to cover is, like I said, we did remove the reliance on the database. And I will show that momentarily for you. The database file is still here just in case you guys do need to use it for some reason or another, whether you don't like this version, want to go back. We do not delete the data, so you guys can always go back. One of the things you'll also notice is the database file was 192 kilobytes. The new storage system is 1 kilobyte. And it's all plain text. You cannot open the database files, but you can open up the new storage system. This will store everything in here, the coefficients, every indicator that you use. And you can modify it manually if you need to. I may request it if you guys have some issues with something. But like I said, this does remove the reliance upon the database itself. Since there's a lot to go over, if you guys have any questions at the moment, just ask them. I'll cover them as best I can for you.
Yeah, as you go over this, Zach, if people have questions, just put them in the chat, and then I'll call them out so you don't have to. I'm watching it.
Okay. One of the other things that I did forget to mention is our software is actually no longer hosted on our website. There's a couple reasons for this. The biggest one is we are limited to the storage size that we can upload, the file size that we can upload. So we have migrated all of our source code to GitHub. It is still currently private. Unfortunately, you guys cannot review all of our secret sauce. However, we do have the releases available publicly. Now, I know that some of the customers are unable to use GitHub. It is restricted for the company. If that is the problem, just reach out to us. We will get you a version of the software as you need. But as you can see, everything is hosted here on GitHub. We have the releases page here for the calibration software. And you can find all of our releases here. For those of you that do not use GitHub, don't worry about it. There's nothing you really need to know about this. For those of you that are familiar, though, you can create issues here. Everything is monitored. We are working on getting automated build control. And as I mentioned earlier, I literally just uploaded this. Ran into a lot of problems ahead of time, but everything is live. Like I said, you guys can go to our website and download it now. And if you're not familiar with GitHub, you do not need to worry about it. Just be aware that it may be blocked by your IT department. And then to go back to our software here. As you can see, we have added a few different meters. As Henry mentioned, we did add our C705P and the G501F. The G501F, for anybody that does have one or plans on getting one, does not read in millivolt per volt.
Mm-hmm.
However, if you do get a calibration certificate from us, we do still give you a reading offset polynomial. Basically what it is it's a very slight adjustment throughout the curve that will better match the applied force. So while we understand that the G501F is only designed for linearity, as Henry mentioned, we do not feel that linearity is as good as curve fitting. So the software can still benefit you there if you do opt for the G501F. So what we're going to do is we're going to get into the Hattie here. This is one of my favorite meters. If anybody's talked to me, I've probably recommended trying the Hattie out, as long as you have access to a computer, which I'm hoping everybody here watching this does have access to a computer. So you can use
Only one phone call. Only one call in, Zach. So we're high percentage.
Oh, okay. So what you'll notice is the load cells that were available are now shown here for the dropdown. Either one of them, you can select that, and that will pair that load cell with the Hattie, and then you can use that throughout the program. One of the other things that I changed with this update, aside from just the light and dark mode, is I have redesigned the indicator screen to make it easier to see that you need to actually select the load cell. So if you didn't catch it, there was an exclamation mark here, and I'm going to add some more meters here in a moment so you can see it again. It will let you know, hey, you need to do something here. The previous one didn't show you a drop down. You had to know what to select. It was a big pain point for a lot of our customers, so I just redesigned this entire section here. For those of you that do use third-party tools aside from our software, there is some basic information here for how to communicate with the meter. These are the commands to send to the meter to actually get responses from them or to do different things. I do not have the full command list there. There's just a lot of commands for a lot of these meters. But we can test all of this. This opens up terminals straight to the Hattie itself. And we can just type in our command here, and we get a response. So you can kind of use this to verify what's actually going on. I may ask you to reset your Hattie, and I'll walk you through the commands to actually send to it. That is how you would do it here. And again, I will help you guys through all of this. You don't have to remember this. You don't have to know any of this yourself. Just give us a call and we'll help you out with anything that you're experiencing. So as you can see, we got the serial number for the first command. We have the net weight or net mass in this case, or sorry, net force. And that's just the millivolt per volt value from the Hattie. And then we can also tear it out and then get the net value again. And you can see that it tear it out correctly. I have received some phone calls from certain people saying that they were unable to tear the meter. This is one way for us to verify what's actually going on. The Hatties themselves have a threshold where if you have exceeded that threshold, generally indicates that the cell has been overloaded or there's currently a load on the cell. The Hattie will just ignore your tear command. So like I said, we may use this for troubleshooting steps.
Hey Zach, well, because I'm the only one here, the Hattie will zero up to what? About do you remember? Is it 1,000 counts, or we'll zero at 0.1 millivolts or 0.01?
Well, so I mean, you can see here that we're already over 0.01.
So it's 0.1.
I want to say that it is 0.1, which is a significant load or perceived load on that load cell.
Yep.
But like I said, I don't know the exact values. I want to say it's like 2% full scale, maybe 5% full scale. I don't remember the exact value.
Yeah. I believe it's.
Yeah.
I believe it's. I believe it's not. I believe it's just 0.1. But yeah. So for those there, that's considerable, depending. And you're not too far off because on a 2 millivolt load cell that would be 5%, and on a 4 millivolt load cell it's 2.5%. So yeah, there's depending on the output of the load cell depends on it. But if you just go with 0.1, if it's not zeroing, chances are there's a significant shift or overload on the load cell. Doesn't, again, careful wording. I said chances are. So.
Yeah, and again, we'll help you walk through all those steps as well. We'll try and do as much troubleshooting before we actually ask you to send it in to us, just for verification. Like I said, that covers most of the indicator stuff here. We're actually going to go back to the load cell section. There's quite a bit that I've changed, and we're actually just going to remove these test cases. Obviously, we don't need them anymore. Now, one of the things that I know that is a big pain point for a lot of people, and one of the reasons why we get a lot of laptops here, is entering the coefficients is error prone and time consuming. It's tedious. We're aware of that. Nobody really enjoys doing that, even though it's only once a year. If you have a lot of load cells, it really adds up to time. So what you've always had to do before was create a name, just call it my load cell. You can give it a serial number. Then
why are you using my password? Why are you using my password? That's it. Oh.
So as you can see, that the values will automatically fill in as you go. They'll create the correct format for you. You won't have to worry about typing everything out, but you do want as much information as we put on that certificate. So I do have a couple of certificates here for you. Let's put this over here. We're gonna move this over here. So what you can see is there's a lot of numbers to type in, and you can copy paste the values. And work your way down through. Now let's say you were on the last one here and you had a little bit of a typo. Program will let you know, hey, something's wrong with this value. You go back here, oh, I accidentally put a decimal in there. You're still good to go. You can still do manual entry if you prefer, but we've gone even further yet. As you can see at the bottom of the screen here, it does say that we can drag and drop the certificates to import the coefficients. So I'm going to go ahead and delete this cell here. And we're just going to drop it right there. And everything's filled out directly from the certificate. No more manual typing. No more having to worry about updates. And I'm going to cover the updates here in a moment as well. You just get a digital certificate from us. Either your sales rep or somebody here at the office can help you get a certificate if you need one. I don't know. Do we have any rules against that, Henry?
No rules against that. My question on this is, does it know the units as well, Zach? That's the one I didn't.
It does actually.
Okay,
we're gonna get to that here in a moment. But
okay.
What I realized was the certificates from 2021, as you can see.
Yeah, it's our NIST standard.
Yeah.
Not it's
actually,
our part of our 2.25 million setup. Yep.
So I do have the latest version here from this year. So I've actually dropped that in here. We're gonna just update that the name now to represent that it's the latest version. Or if you prefer, we can name this my load cell. And it will not change. I say that. And it will not change just from dropping a new certificate in there. It will keep your name the same. So you guys that have a bunch of team members that have 10, 20 cells out there, and you want to make sure that they're grabbing the right one every single time, you can put custom names in here and it will not affect automatically updating the coefficients for you. So in the meantime, we're going to grab all of our standards here, as Henry said. These are the ones we use here in the office. And it automatically created new load cells for me. Didn't have to really worry about anything. Just put them in there for me. One of the other things that if you guys only have one certificate to upload at a time, which is possible, it will notify you to say, hey, load cell that you're looking at right now is not the one that was contained in the certificate. Do you want to upload the one that you are looking at, or do you want to update or create a new instrument? And you have the option. It walks you through what steps you have to do here. So we're just going to update the existing instrument, and the information's there again for you. Now, as you see, I have a bunch of certificates here. Doesn't matter what certificates you have, doesn't matter how many you have, you can drop them all in here. And it'll import all of them for you automatically. If the load cell already existed, it will automatically update it. If it doesn't exist, it'll automatically create it for you. A lot of this information is covered in the manual. Again, if you guys have any questions, definitely reach out to us and we'll help you out. What we can notice is one of the PDFs did not import correctly. I can't show you because it is customer information, not about putting all of our customer information out there. This was not one of the supported certificates that we have here. Currently, we only support the E74 and single run certificates, which is, would you say, like 98% of our calibrations here, Henry?
The E74,
And single run.
yeah, and single run about 95. ISO 376 is becoming, it's always becoming more popular, but it's trailing. It's about 5 to 10%, depending on the year and who has their systems due.
Yeah,
but yeah,
and right
close
now,
to 90 is a 90 is a fair guess.
Okay. Right now with the ISO generation, it's done through another system, and it's a lot harder to parse. It is something that is planned to be supported in the future. I believe we are working on new cert generation in the future as well. So as we get more and more cert styles, the program will include those new styles as well. Like I said, I am working on getting the ISO in there. But for the time being, this, like I said, covers majority of our cases. You do still have the option of copy pasting, manually typing it in, but the program will help you through that. And as Henry mentioned, we do have there's newtons for you. So it did automatically identify that the cert was done in newtons. It put the value in there for you. It does also identify whether it was tension or compression. And like I said, it doesn't matter what your name is here. It only looks for your serial number. So you guys can keep the serial number the same year after year after year. Don't have to worry about updating it. You can set your name to whatever you want it to be. It'll be persistent throughout the year as well. The import system will just always look at the serial number, say, hey, I have the serial number or I don't, and it'll create a new one or update the existing one. That said, I am just going to put some information in here so I can reference it a little bit easier. I will just do then I know that my load cell is one of our reference cells here. We can get back into here. As you guys noticed, I did the Hattie earlier. I'm going to add the 4215 and the interface because I want to bug Henry today. And part of the new indicator discovery we have made it so that it actually detects what model you're working with better. And apparently my 4215s are having anxiety today too. They don't want to show up. So what you can see is, like I said, there is still a warning here letting me know, hey, you need to select a load cell. It doesn't matter which one you select, it'll just let you know, hey, you need to select something here. So you can see you go back and forth, still saying select load cell. And I'm going to say, I'm just going to close this and then be like, we're going to let you know, hey, you're missing a load cell that is not assigned. So no longer have to worry about forgetting to set it. Program will let you know, hey, you have not set anything yet. You will not be able to use it if you do not set anything. Now we're just going to ignore this and say yes. And if this is connected or not.
We need a live video of your office with the rows of indicators and stacks of
Yeah, I think
all
I
the equipment.
have 11 or 12 different indicators in here. I have 3 4215s, 2 Hatties, a DSC, and I have a whole bunch in here. So we'll run into some kind of problem here. Again, we're going to close out of this. We're going to get the error message, and we're going to say no, we don't want to close. The program will automatically jump to an indicator that does not have load cell selected. As you see, it switched to the interface this time around. It's something that I have not gotten integrated yet. One of the, I'm assuming you're talking about which models are set here. As it is right now, it does not remember which models you search by default. So you would have to select manually every single time, unfortunately. I'll put that in my list of suggestions here. So next release I should hopefully have that fixed for you.
You'll just remember on that side of things. You'll just remember the last selection and queue it up, right?
Yeah,
so if somebody selected 3 or 4, if they were doing summation, which Zach hasn't gotten into yet, it would just default back to that.
Yeah. So
then,
the way the program works is you have to search for the indicators every single time you use the program. But let's say you guys only ever have a Hattie at your company. You can just click search indicators. I'll get to here in a moment, Paul. So the future update would be that if you guys have a Hattie and a 4215, you hit search indicators, it would automatically save your 4215 and Hattie as preferences in the future. Let's say this time around you only use the Hattie, you search. The next time you open the program, it'll only have the Hattie selected. You can search, or you can change to different model, add more models, get rid of them, whatever. So that's kind of the idea there, is that we can have a bunch of different options. So for Paul, we have not yet tried this under Windows 11 yet. As you can see, I am still running Windows 10 on my system. If this is an issue, I will have to look into this. If you do still need the older version, get that out to you. But no, you should not need to reboot the computer. You should not need to uninstall it. It should automatically update for you. I'll tell you what, Paul, let me reach out to you after this webinar, see if we can figure out what's going on for you. As far as I'm aware, it should work, but let me just follow up with you. Anybody else that's having issues with this, just leave your information here and I'll get to you once the webinar is over then. So moving on to the next screen, as you can see, this has changed quite a bit from what you guys may be familiar with. Some of you did download version 1.1, which has a very similar appearance to it. Not much has changed visually in this version, but for those of you that did not get 1.1 and are still using 1.06 or older, this is going to look significantly different. Now we'll cover all the new features here for you. At the top here, you can see that we have different settings. We can turn mass conversion on or off. So you can either do force or mass. If you are doing mass, you can set your local gravity here. You want it to be 9.8. What is that? You're further into the atmosphere. You have a lower gravity. So your values would be a little bit lower with that. Fortunately,
Yeah, there's still additional errors there. That corrects for gravity.
Mhm.
There's still material density and air density.
Yep, yep.
Those are additional components of uncertainty, but it gets you closer for those that want to get closer.
This is why I have Henry here, because I don't know a lot of this stuff. I know the basic numbers, but Henry definitely fills me in on a lot of the technical calculations. One of the other things you'll notice is units. We now have support for a lot more units. Previously, the only thing that was supported was newtons, pounds, kilograms, and kilonewtons, I think. So now we have added ounces, tons, decanewtons was supported before, as well as grams. For texture guy, we can do that too. The biggest reason is either it was not a cert that was generated by us, it doesn't have coefficients there, or something else is going on. I have not
Yeah,
been able to
so
troubleshoot everything yet, but
we can make this real easy. So at the end, the questions are great. At the end, Zach can go through the stuff, and at the end, he can kind of stay on and even troubleshoot with. I think we can do this, or we can do a Teams call or something. Either way,
yeah,
we can
we can
solve
do that
this
once.
stuff.
Yeah, once we get done here, we can have everybody that's still having issues stick around. We can try and troubleshoot anything there, or if somebody prefers us to reach out to them directly, we can do that as well. So the settings here, this is all for the calibration. This is for data capture. You guys can set whatever units you want, whether you want to measure in newtons, kilonewtons, grams, doesn't matter. We use pounds here for the most stuff, but like I said, kilograms, newtons, all the unit conversions are there for you. If you need more unit conversions, please let me know. We'll add more conversions in there as well. This drop down is for the decimal precision or the resolution that you want to see here. By default, 1 is selected, but let's say you want to see 3 decimal places. You can select that, and as you can see, the values up here update for you. Then this one here that I skipped over is the reading interval. This basically says how fast we're going to update the displays within the program. This does also send a message to the meter that frequently. So if your meter doesn't respond within 100 milliseconds, it's not going to hurt anything. The display just won't update until it gets a new response. But if, like the Hattie, your meter responds within 20 milliseconds, this can control how fast your display is actually updating. If you only want it to update every second, your guys are too overwhelmed by how fast it is updating, you can delay how long the update takes. So we'll set that to 100 milliseconds there. It's default value. As you can see, the interface does not have a value written underneath of it like these ones do. It lets me know, hey, I do not have a load cell selected there, so I need to set something if I want to use it. We're just gonna go back here real quick. Change this one to tension, and we'll put our standard on there. Now you see they all have names. Everything is configured to get readings now. And once you've added everything, the little reading pane actually closes for you. If you realize that you need to make an adjustment here, let's say you only wanted whole numbers, you can open this back up by clicking the little cog here. If you need to add a new indicator, forgot to add it, you need to get readings from it, little plus here will open the other pane up for you, and it'll let you add that indicator in. Once we turn the readings on here, you can see that we have 91 pounds down here, 1 pound up here, and nothing here. Something else I do want to point out is this offers compression and tension coefficients, so we can actually switch between tension or compression. Unfortunately, it does not remember, so if you have a load cell that has tension and compression there and you normally want to use tension, unfortunately, it will default to compression for you. But if you only have compression coefficients for you, compression coefficients for the load cell, it'll stay as compression. And you will not be able to change it. You don't have tension coefficients to switch to. Same thing if you only have tension, it'll default to tension for you. You would not be able to switch to compression since you do not have compression coefficients. One of the other things that has stuck from previous versions is you are able to switch from your calculated reading or your polynomial reading to millivolt per volt. This is helpful for diagnostic reasons. Some of you guys do also prefer to see the millivolt per volt while also being able to read the total value up here at the top as well. I'm going to make this a little bit bigger just so we can see bottom cell here. Now what we can do is we can actually say, I don't want to include that in my total. This is a summation that Henry was talking about earlier. Now we only have, let's switch these back. We only have 1 pound added. This is still reading 91, but we only have 1 pound reading. If we expand this to a couple more decimal places, you see there is a little bit of leftover numbers there. Polynomial equations get a lot of decimal places, so you have to kind of cut them off somewhere. It does round to the nearest whole number. One of the use cases that we get asked about but have not really covered officially is being able to use the software for a reference cell as well as a unit under test. So let's say you have a UCM or another one of our tools that is able to apply a force. You want to be able to read from your reference cell and capture the data for your unit under test. That is where adding values to the sum matters. So let's say this is going to be our reference cell. We want that to be added up there. In our lab, we actually use this for our, 2.25 million pound UCM. We have 3 reference cells, which are actually the coefficients that I used earlier in here. We have 3 reference cells that we add the values all together. We use that to actually hit our target values. So we need to make sure the equations are correct in here as well. But if you have a unit or test that you want to test out, when you capture the data, I'll cover the data capture here in a moment as well. When you capture the data, all the information is stored here, as well as whether you were in compression or tension, and whether the value should be added to the sum or not. So see that here in a moment. But the goal is to be able to record everything, let you guys work with it at the end then. What I'm going to do is I'm just going to clear this out. And we're just going to add some values in here. And we're just going to capture some random data. And one of the things I want to point out to you is the peak and valley up in the top right. Oops, that's wrong cell. As you can see, as I'm applying force to the load cell connected to the Hattie, my values are changing and the peak and valley values are changing as well. Now, when you're first starting out, you can click reset values, and that'll set both the peak and valley to the minimum values. If the value exceeds that, it will automatically update. So as you can see there's a small update. The peak went up, valley went down. And whenever you capture data, the values will reset as well for you. Let's say I want to tear this out, the value is too high. Okay. The value was just a little too high for us. So now you can see that our peak's a little too high as well. We're just going to reset the values on that as well. So if you guys need to use the peak and valley, it is there for you now. If you don't, just some extra numbers that you can just ignore then. And what I'm going to do here is I'm going to clear this data, grab the heady, and we're going to switch units to, let's say, grams, 2 decimal places. Then we're just going to capture the data there. As you can see, the cell was obviously designed for tension, and I have tension set up in my office. Do not have any equipment. Anyway, that's something you can get me. You can get me a UCM for my office too.
There you go. Okay, so you had a question here that is relevant to that. What is the purpose of the symbol plus in green?
Okay, so this is for the active indicators. So if you forgot to add an indicator, this will open up the drop down again for you. This allows you to
Take them away and add them.
Yep. Yeah. And same thing with the X. The X will remove an indicator for you, or in this case here, it'll just close that section for you. Does that answer your question, Nelson? Okay. So what we're going to do is we're just going to put some values in here. It's up to you guys. You do not need to use target values. Some of you do use them, so you can kind of record what you were trying to hit and what your actual value was. And let's just put some extra information in here. And we're going to go over to the report tab. This is something that was new for version 1.1. This was a requested feature from previous versions. People wanted to see how much of an error you would actually have. So what it does, it takes target value, takes your captured value for whatever load cell you're using. Right now, we only have a tension load cell, so you would have to change from here which one you want to view. But it would compare this. It would calculate your percent error. Anything over 1% error will be colored red. Anything with less than 1% error will be yellow, and if it's no error, it'll be white for you. Yep. I think you were the one that actually requested it, Nelson. You're very welcome. One of the other things that was requested as well is being able to make changes to your millivolt per volt value. I know that this is probably not something that a lot of people are going to use, but it is there if you need it. The program will let you put in any value you want, so you can go up to 0.1 for you. Like I said, however you guys want to use this.
What's the purpose of that? Do you know?
It was requested.
Okay.
That's what I know. It's more up to you guys.
Is it a rounding feature? I would think it was a rounding feature. You just round your millivolts up.
Could be, possibly, sure.
Yeah, okay.
But one of the other things you can do on this screen, let's say you realize that you really didn't want to use 2 decimal places, you just want to use 1. Now you see that these values that were 0.02% that were yellow, now the values are dead on.
Yes.
So that is very helpful for helping reduce your error. Oops, let's go back up here. Yep. So now all these are dead on their percentage. And if we go back down, you'll see a little bit more error. Generally, you're not going to need unit conversion here on this page, but it is there if you need it. So let's say you realize that you weren't supposed to be doing grams, it's supposed to be newtons, your numbers were way off. You can switch units here as well. Everything will update in real time for you. One of the things you guys have probably noticed at this point is the equations are updating as I'm making these changes. These equations are to help show the transparency for the calculations. This is the exact equation that the program itself is using. And in order to make this easy for you to verify, let's say you have an audit coming up and you need to verify the information that the program is calculating, there's a little button here to copy the keyboard, and it even tells you copy the polynomial equation, and it does create it as an Excel-friendly format. Let me open up Excel here for you. Ooh, sorry for blinding everybody. What you can see is that there is an equation up here at the top. This is the exact equation that was copied from the program. And it calculates the same value there. Now, Excel only shows you as many decimal places as you let it. You can have it show more if you need to. Again, more up to what you guys need. This one down here is the unit conversion paired with gravity if you're using mass, as well as the resolution, the resolution equation that is used as well. If we capture the values for that, you can see we get the same values within our program as well. Any questions so far up to this point? Because the next step is the Excel export.
So as you're doing that, we've learned if you just want perfect repeatability, we just raise our resolution to get it for us. I kid, but that's part of the reason that people insist on putting resolution in uncertainty budgets, because manufacturers or other people could just use programs and make everything read perfect, and then you have your repeatability data is perfect. So then the resolution at one point becomes dominant.
Yep, exactly.
So you've taken a lot of numbers there, Zach, to export to Excel.
Yes. So
620 pounds, man, you're getting stronger.
Oh, this is grams force. I can change that. Go back to pounds.
Oh.
Not quite as strong as you thought it was. Yeah, I could definitely get that added in, Kevin. Obviously, this one is live currently, so it's not going to be in this version, but there is going to be some bug fixes and stuff like that. It's a lot of this was last minute, so there is likely to be a bug somewhere. If you guys find one, reach out to me, let me know. Try and get a new update out as soon as possible then as well. And I have a spreadsheet that our engineering manager created for us to use here at the office. We'll just maximize this. This is a spreadsheet that we use to generate some E74 certs, something that is outside of our normal program that we use. As you can see here, there's a lot of information. I'm not going to cover it. This is not part of the demonstration itself. But what this is for, it's for demonstrating how the Excel export works. Within the manual, it covers very specific information about how the data gets exported in Excel. You're not required to use this extra feature, but I'm going to show you how to take advantage of this. I do actually need to pull up my instruction manual here. I need to know the values myself. Just give me a moment.
So while Zach's doing that, yeah, everyone, thanks for the feedback and the questions that are currently coming through. They're really good, and that gives some, as Zach said, I'm sure there's a bug or two left. All software he's been testing, and he's just been finding some things that we want to get those right. So in the next update, Zach has some notes too on things that are pretty easy to add. So thank you for that.
What's the oddball? So is it 58853?
What's the one for?
58853. Yep. Okay. So what I'm doing is I'm actually creating named ranges here. This is a feature that allows you to tell the program where you want it to put the values for you. So what I've done is I've named my force applied column here to be target values. You can see that up here at the top. And apparently this did not want to stick. And this cell here is named RAW 5883.
Yeah. So that's in the instructions, and once people would do this, you just save the Excel sheet, and it's going to remember it.
Yep. And I'll give you guys a little brief presentation on this. This allows you to have a single template and be able to have the data export directly into the spreadsheets as you need it to. There's a lot of information that is exported by the program, and I'm going to cover that here in just one moment. You're not required to export to an existing spreadsheet either. You can start a brand new one every single time you export the data. You can save that however you like as well. So now that I've saved the spreadsheet.
Yeah, you can do this. Yeah, right. You can do it either way.
Oh. Well, that's crappy. I didn't know he had macros on this.
Oh,
maybe
yeah,
it still works.
Mm-hmm.
I'll have to find out. Nothing's blowing up.
Nope.
Okay. It took a little bit longer. There's a lot of information on that, a lot of equations, so it takes a little while for the entire system to process everything, but it does eventually get through it all. As you can see, this is the final / overview page of the program. This is all the values coming together. If you are reading from multiple values at once, for example, you have multiple references that you need to read from, this does the summation for you. If a value is not summed up, these cells will turn green for you. And then the total shows up here, and you can see the target value is right next to it as well. Obviously, our data is not very good because I'm doing this in my office with no machines. But this kind of gives you the overview of what you're looking at. As you can see, there's also all the units here. These are values per pound. So there's 1 pound per pound, 16 ounces per pound. There's 1/2000th of a ton in a pound. And these are all ratios to a pound. Resolution is also listed here. And let's say you actually want to change this. All your values in the Excel spreadsheet will automatically update. They are all equations, every single one of them. So if you need references on how to make use of either table or how to make use of named range and you're not familiar with it, you can reference the equations there, create your own spreadsheet. Worst case scenario, you guys can reach out to me. I can try to help you, but obviously I am busy, so I can't guarantee much time with you. But quick questions, stuff like that, I can definitely help you out with that. There are also a couple of other pages here, or a couple other worksheets. Every single one of the load cells that you capture data from has its own spreadsheet. It will list all the coefficients that you have for that load cell. It'll show you the values that it captured. And then it'll also do I don't know why that one's blank. Let's look into that one. It'll also do the calculations for you. So as you can see, this is the polynomial equation. May not be able to see that from just looking at it. That is a polynomial equation. After that, we divide by the resolution, we round, and then multiply the resolution. If you do mass conversion, the mass conversion is put in here as well. And if there's unit conversion, the unit conversion is in here as well. All of the equations are there for you to visually verify how the program is operating. Again, if you have any questions, please reach out to us and definitely ask us what's going on here. As I mentioned, all the coefficients are listed for you. You can reference them easily yourself. They all have their own named range as well. If you have any questions, you can find it by selecting the named ranges. And this is the roll section. And this is calculated.
And the only confusing thing here is I'm assuming negative coefficients are compression and positive retention.
Yes. Negative transition for a future update, but yes, negative is generally compression, positive is generally tension. So back to the main page where I made some changes earlier. You see that it automatically filled out my target values for me. The named range also increased in size. If you had data there previously, the data will be overwritten. It is very important to know. If you have, let's say you do 5 runs within the Morehouse Calibration software, but you only have 3 runs in your spreadsheet, your runs will overflow into these other cells. So definitely be very aware of that. This Excel export is not marked per se. The only thing it looks for is if the named range exists, and if it does, it puts the data in there and expands named range to fit it. But this allows you to automatically fill out your spreadsheets as needed. I think that we actually have some, so you can see some of the data has actually been pulled in for you. These are the raw values here. I think these are the adjusted values. And coefficients are even calculated for us. I don't know, Henry, have we made this available for customers yet, or is this only internal?
No, it's internal. It's going to be available with the automated UCM and PCM. Both UCM and PCM are in final test. So those that wanting, just in general, training technicians, everything is difficult. Turnover's high, and a lot of companies are going to automate anything. And those that want automation of, like, say, the PCM or UCM, that is coming very shortly. There's going to be units out for test. If somebody wants to be a beta tester for that, please contact us. Anybody listening on here or anybody that watching online, we are looking for people that would want to beta test, which it should not be that bad of a beta test, because we've had the UCM we've had in test for over a year. It's just now what Zach's showing is an Excel method to do some almost anything calculations, because they can be manipulated a lot easier than a full-blown code base, which we are working on as well. That's just going to take a while to get everything programmed, every scenario programmed in. If anybody's familiar in metrology with decision rules, go look at decision rules, and you're supposed to have the contract review with your customers on them, but that's a compliance pass fail. There's easily over 50 decision rules, and I think we've baked in about 6 or 7 right now, the common ones. So there's a lot there, and a lot of use cases and scenarios, and as received, as returned, adjusted, all different things. But yeah, and there, Zach just pulled it into a new book. But yeah, if you have your own, I know we told people they have their own Excel sheets. Looking at that file structure and how to do that, it might be a huge time saver for the load cells, and just how it's not that difficult to do. You can even do drop downs, and Excel coding has gotten real easy with Lambda and declaring variables, and some cool stuff that Zach, James, and the rest of the team can do that I'm learning at a snail's pace, but it's still pretty freaking cool. Anyway.
Yeah, so we have about 15 minutes here, so any questions you guys have that I've not covered, definitely ask. Once we wrap up here, anybody that has been having issues, definitely stick around. We'll see if we can troubleshoot. I have a lot of capabilities on my machine as well to see if I can figure out what's going on for you. But something that didn't cover is that you guys can have multiple templates here. So let's say you have one that's for example, an E74, ASTM E74 spreadsheet that you want to dump that into. Have a template for that, set your named ranges however you want. And then you can have a single run template, and you can have an ISO template. You can have a bunch of different templates. You can put your named ranges wherever you want, and just have your technician or yourself select that workbook when you go to export. Something to be aware of is if the workbook exists, there is a prompt that says, are you sure you want to, it says replace, but it's just updating it. Are you sure you want to update it? If you don't, you can create a new workbook and it will create it from scratch. This is something that Paul had asked about. I didn't show it already, but these tables will automatically be generated for you. The capture data, calculated, everything will be put in there automatically. Something to be aware of if you are overriding an existing, or if you're updating an existing spreadsheet, if the table already exists on your spreadsheet, the table will be wiped of data. So if you put any notes or anything like that in the generated worksheets that the program creates, just be aware that those notes will be cleared out. Named ranges that you've added into those pages will also be cleared out. So generally, we'd recommend having a separate page that you guys would reference. That could reference those individual pages. You guys could use drop downs, however you want. You can get very creative with this, but this is the best way to allow you to update a template or update an existing workbook with all of your information that you've captured. There was a minor update to, go ahead, Henry.
No, I'm sorry, Zach. And most people are, Zach went over three indicators here. Most people are just using one indicator, one load cell, and it's real easy to export that out, or even rudimentary technique of copying pasting out. But, the new features are quite useful if you can spend a little bit of time to define them and have it auto populate.
Yeah, so there was a little bit of change here to the help menu or the help tab. Really, there's not much information here, but there is some email. If you guys do need to reach out to me, you don't remember how to spell my last name, don't worry, I forget how to spell my last name too once in a while. You can just reach out to software@mhforce.com. I think I'm currently the only one that's on that one, so you can reach out to me and I'll respond to you. You can also reach out to the sales department. It'll get you to the correct sales rep in case you lost their information or whatever. And then as well as our website and directly to our software as well. And then, like I said, percent error, report tab. There's a lot of different things that you can do here. Any of the changes you make are real time.
Yeah, I think there's go ahead. Sorry.
So like I said, this was something that was just requested. I'm not sure the purpose behind it. I put it in here, but the report tab itself is designed to kind of just show you percent error. If you do need to make any adjustments, like I said, you probably don't, but if you do need to make any adjustments, you can make the adjustment here. Something you can notice is the values are changing down here. So depending on which cell you select.
All of that looks to me like that's all rounding. Because if you look at the equation, it's a rounding error. So you can round to, you can change your resolution. If you find that, 400,000 counts is too much on a 4 millivolt cell, that you can put the millivolt at 00010 and then you have 40,000 counts. You can do the same thing by just changing the resolution. I don't see the need. Again, it was something that, like Zach said, somebody asked us for, and Zach was kind enough to put it in. It certainly looks like rounding, and I would handle that through resolution and report that in my uncertainty. I don't think I'd do anything with the millivolt readings.
No, it is not an offset. This is physically changing the captured millivolt per volt value.
Yeah, it's rounding.
Yeah. Paul asked if it was an offset value.
Oh no, it's just rounding.
Yeah. This they said this was just something that was requested. You guys need it, use it. If you don't use it.
Yeah, keep it at 0. I just would keep that at 0. It is rounding. I get if you know where you probably would use this if you have an unstable situation with power and you say, look, my numbers are just erratic all over the place. It's just easier. I want my millivolts to volts to be steady, and I change it to read by 2 microvolts, 5 microvolts, or even 10 microvolts. that would be a
Mhm.
situation. But then that really messes you up on your uncertainty and what you claim if you're calculating uncertainties correctly. So I try to stay away. I really try to stay away from that. And these things are now doing peak and valley, and Zach has it set up. You just capture the values. You can still capture them with the space bar, right, Zach, on here if you go.
Yeah, so once you hit capture data here, you can keep hitting enter, you can do space, whatever you want to do.
Right.
This keeps focus once you've done it once. Received version 1.1. Okay, so
That might be what happened with Paul's too. I don't know. We can get into that.
yeah,
Zach, do you have anything else to show? Because what we're going to do is we'll handle the individual questions. There's still a lot of people on this call. Handle the whatever Zach wants to wrap up with, and then whoever wants to stay on, Zach will stay on and handle the individual questions. So, does anybody? Zach put that in the window. So the question now is, does anybody have any other questions, generalized questions, besides the ones that we're going to handle afterwards? Like the after ones were Windows 11, the afterwards with making sure the software is on GitHub. Does anybody have just generalized questions on form and function?
yeah. I mean, it really doesn't matter what your question is. Hopefully, it's more technical because my anxiety is already killing me now at this point. But
You're fine. You've done a good job with all of this. So what we're going to do for we're going to end the recording now, and then go for just general questions. So if you're watching, you watch the recorded version. Thank you for watching. If you have questions, it's as Zach said, it's software at MH Force, and also Z Shear
thanks, Paul.
at MH Force. And yeah, everybody likes praise, and Zach just did a phenomenal job. Now, that's it for those that are viewing us on YouTube. The people that are here live, we're going to handle Q&A.